Hi students, do you know what is resolution of vector? Let me explain. Think of a man is pulling trolley. What it is happening here? We can see two things. In the horizontal direction along x-axis we can see the trolley will move forward, and second case we can see in the vertical direction slightly that force lifts up, right? It is moving little upside. So that what happened, normal force decreases, means friction will be less, right? Whenever he is pulling with an angle, what is happening? In the horizontal direction the trolley will move, at the same time little push it will give this force to the trolley. These two things is happening. Now the resolution of vector is telling about the vector, whatever we have taken the vector with an angle theta, for example, this angled force, how much along the x-axis is applying or acting, how much this force is acting vertical direction, that is what resolution of the vector. What is resolution of the vector? This vector we are going to rearrange as a one more vector but without any change, right? How we have to change? We have to do the projection. This vector projecting on x-axis as well as this vector, the same vector is projecting into one more axis, perpendicular axis, right? Here simply we can say the resolution of the vector is nothing but the splitting of, the process of splitting of vector into its vector components. The splitting of vector into its vector components, right? Here 2D I have taken, so that here we can split this vector into along x-axis as well as y-axis. If you take three-dimensional, we can split into three, right? X-axis, y-axis and z-axis. That is the thing. Now along x, how much it is acting, this one. In the y direction, how much it is acting, that we have to know. That is only resolution of the vector, right? Here x-axis and y-axis vector I have taken same vector a bar I have taken, or else the force which is pulling the trolley. Now with the x-axis making an angle theta and y-axis remaining 90, I mean fully 90 if you take now, this is 90 minus theta. The small part 90 minus theta. Now just it is like a shadow, or else projection we have to do on the x-axis, right? That is, now if you draw a dotted line to the x-axis, perpendicular line, it forms like a right angle triangle. For making calculation easy I have taken, now see, for example here you can think of ax. This is the point x, and here y, the projection is y. This we are calling as ay. Now this ax is nothing but horizontal component, how much is giving towards the x-axis. Ay is the component, how much along the y vertically happening, that is the point. Now we can find out easily. This is ax, hypotenuse a, theta we know that. Horizontal component if you want to find out, we can do the horizontal component we want to know, so that we can do cos theta equals to, what is that? Cos theta equals to ax by hypotenuse a, so that what is that? Ax equals to a cos theta. Now this one we want, vertical component ay we want, here 90 minus theta, so that cos 90 minus theta we can find out. Cos 90 minus theta, if you find out, what will happen? Adjacents by hypotenuse, ay by a, ay equals to a cos 90 minus theta, a cos 90 minus theta equals to sin theta, ay equals to a sin theta. We found that a by a sin theta. We found x, a cos theta, so that a cos theta is acting towards the x-axis, towards the y, A sin theta means horizontal. This force, A force is given, we have given, right? Applied A force. This A force is acting along A cos theta in the x-axis, Ay in the y-axis, that is A sin theta. This resolution of the vector we will use in our daily life applications. We will see the cranes. Cranes will lift the heavier objects. Heavier objects it will lift. Horizontally it has to move. At the same time, it has to lift the block and it has to move. There we will use resolution of the vector, because based on the calculation of the x, horizontal and vertical, based on that they will calculate how much tensioned rope they have to design, how much strength it should be, like that in engineering applications they will do.